All right. So now we're gonna do even more cool stuff. So what we just showed, just to kind of reiterate, we showed classification, like an example, and just so you know what's going on underneath the hood, that is an example of what is called transfer learning. So what happens is that you can take a neural network and you can have it learn how to classify images, right? Now, normally you need a neural network. You need to give it like 100,000 images before it learns how to classify them properly into categories. But we only gave it like 40 or 50 images per class or 100 images per class. It's not so many, right? So why does it do such a good job with such a small number of classes? Well, the reason is because it does actually something called transfer learning. It downloads into the browser a model, the same model that we used in the first example, which just said this is a conch, this is a cat. It downloads that neural network, and it uses that as a sort of input to a smaller neural network that's trained just to recognize the 4 image classes you give it. So basically, we use the big neural network as a feature extractor, and then the feature extractor extracts features from each of the images, having been trained on many millions of previous images, and then it uses those to input into the small neural network. And then because the feature extractor is already giving us such high-level information, we're not starting from just pixels. It requires many fewer examples to do a good job of classifying. So that's kind of like that's what's called transfer learning, and something you'll come across a lot if you operate in this field. So besides for that, okay, like from our perspective of like what we're doing in this course, so we have a basic image classifier, and it does something cool in the browser, right? Like, and maybe the example that I showed is really dinky. It's just like playing a guitar. But imagine now that you can create a whole game which reacts to, and in fact, we're going to see that in the next example, or in 2 examples from now. So it's you can create games, you can create interactions in the browser, and this stuff can be easily uploaded to a web server. So if you were to take any one of these folders and upload it exactly as it is to a website, it'll work that way online, right? So that's kind of a nice feature as well. Okay, so let's look at now these regression examples. So I've already mentioned classification. We're going to look at the regression examples, and regression is the other kind of supervised learning, right? In classification, what happens is you say, this is an A, B, C, or a D, right? It's categorizing the images. Regression, instead of categorizing, you have a continuous value that you're predicting. Okay, so let me show you the regression example first. You take regression simple and drag that into brackets, and then click index.html and open that. And let's look at this. This is going to look very similar, except instead of having a bunch of categories, you have a slider like this, right? So this slider is a continuous value between 0 and 1, just the one that on top. So let's associate some values with let's do like a facial gesture. Let's see if that works. That might actually be kind of flimsy. How about this? I'll put the slider all the way in the left, and I'll put the tea bottle here. I'll go add sample, so I'll hold down some samples here, maybe move the bottle around a little bit. I'll kind of keep it to my left, roughly. And then I'll put the phone, and I'll go all the way to the right on the slider. Now I'll click add sample. And then maybe like in the middle we'll just do me. Like something in the middle just be straight. And you can kind of move around a little bit. And now you hit train. And now it actually controls continuously the x value. Or, oh, and then, of course, then you have to hit run. There we go. So now we're controlling the slider with the camera. And so we can get to control a continuous value, right? So, and another thing, now first of all, notice that it's very jittery because the slider's very sensitive. So there's an extra slider down here that's called lerp, and lerp stands for interpolation. It'll smooth the value. So if you turn the lerp down really low, it'll be full jittery. It'll just go exactly where it's supposed to go at all times. If you make the lerp really high, it'll smooth it. So it'll kind of slow it down. See, it's much smoother now. Now the smoothness comes at a cost though. It's a little bit less reactive. So it's easing. So you have to kind of pick your trade-off. Like you either want it to be very reactive or you want it to be very smooth or somewhere in between. So that's what the lerp controls. And by the way, you've probably also noticed these learning rate, batch size, epochs, and hidden units. Those are all things that control the training parameters. So you can potentially mess with these numbers. We're not going to talk too much about what they do because we haven't really talked about how neural networks are trained, but they affect the quality of the model by increasing the parameter size or increasing the layer size or training for longer, things like that. But we're not going to really talk about that in depth, so just like experiment with that if you'd like to. Okay, and now again, like we can look at the code and you'll see that the code is all the way down here at the bottom. And we have this slider equals 0.5. And what happens is whenever the slider gets a new value, it calls predict and sends predicted values to our function. It comes as a list. So if there's more sliders, there's actually going to be more of these. But we just have one slider, so we can just grab predicted value 0, input that into slider, and then we use slider right here. Basically, it's between 0 and 1. So I multiply it by the width, and that controls exactly where the rectangle is drawn. Okay, so like really, really bare bones template doing regression. This is what's called regression. You probably, if you've ever taken like high school statistics course, something like that, you learn regression, like linear regression, fitting a line to a set of points. So that's like a pretty standard thing. And you can use machine learning to do it. Right, so now let's look at the slightly more complicated example of this, which is regression Pong. You can already guess what that is. So basically, we're going to input this regression Pong, click on index.html. This has much longer code because this is borrowed from a game that you can find in the P5. I forget where this is found. It's somewhere in the P5.js website, I think. Someone else wrote the actual Pong game. I just hooked it up to our script. And if you run that, we're going to train the thing to do Pong. So here's what I'm going to do. Train left on the bottle. And train right on my phone. Okay, and then and then click train. So it'll train it for a second. Loss will go down to 0 something, and then click run. Now you see that like it's again like we have the smoothness. Now here's the deal. So the slider controls the velocity of the paddle. And I forget which direction. One of them will make it go down, one of them will make it go up. So whenever you're ready, you can hit the space bar and it'll begin to play. So there's, okay, I've already lost. Down, oh. See, okay, so it's a little bit, it's hard, like I should make it a little bit more easy to play. Oh, does it not start over? Click to continue. Oh, okay, so I seem to have a bug which doesn't let it continue after you lose the game. So I forgot to program that. I think No, it should. Play game equals true. Mouse. I might have forgotten to make it reset. Make it start again. Play game equals winning score. So maybe if we reset the scores, that might change. Yeah. Anyway, I'll have to figure out how to restart the game. That's just a bug. But basically, like the idea is we can do this again because that was really bad. Like, let's try to do let's see if I can actually, because I actually played this the other day and I won. So it's pretty hard to win. I made the game is it's probably like a little bit too hard. Okay. Now I'll train it again, and then we can turn the lerp down really low, I think. Okay. Oh, I don't have a very strong signal for the bottle.
How do you get around the not restarting part?
That's a good question. All right, I'm obviously not so good at this game, but the point isn't to play Pong. Like this, the idea is we have a functioning game, and then maybe if I hit, okay, I'll figure out how to restart the game later. I think it should be I thought there was I might have forgotten to carry something over from I know where it is. It's gonna be. I can find it in here. Mouse. I don't want to debug in front of you, so there's a way to make it restart. It's just a program, so there's some sort of a bug in my logic, and it's a long program. But the idea is, okay, we have these programs, and we can program a game, right? They can create and that's what happened. That's what we looked at yesterday. We looked at a big Pac-Man game, and that is that was made by Google, right? You have the same tools at your disposal as that whole company, and you can make a much cooler game than them, especially if you have some proper web design skills, right? So I'll let you play with that a little bit. Maybe okay, play for 1-2 minutes, and I'm gonna see if I can figure out how to restart this stupid game. It's Okay, I think that should solve it. Let me just see if that does. This is the state of AI. Okay, let's actually train it, I guess. This is going to be a really stupid way to play this game. Okay. Okay, now it should. Okay, yeah, spacebar now. Okay, so this is what you need to add to the code to make it restart the game. If you go all the way to the bottom, in where it says play game equals true, if you just add these lines, that should fix it. So then you can just keep on hitting the spacebar to restart the game. Make sure you don't make any typos. Sorry?
Should 3.3 be a comma at the end? Why semicolon?
Why semicolon? So you use semicolons to end. Oh yeah. It actually doesn't. You can use this is the same thing as this. Like you can actually, that's accepted in JavaScript. But yeah, like a little better would be to just use a semicolon. Yeah. Sorry? How many lines?
Yeah.
Like 300 something, 48, 49?
28,000 lines.
What? Oh, you're in the wrong file. Index.html. If you're in the JavaScript file, that's gonna have like all of the. That's basically all of Tensorflow.js. And yeah, if you accidentally click into one of these long files, like the tf.js examples webcam transfer learning, like it might freeze like brackets for a while because it's a really huge text file that contains like basically the entirety of Tensorflow.js, and we don't need to look inside it. But brackets will try to open it.
What's the map file?
Sorry? I'm not sure. That's some sort of a. I think it's some sort of a JavaScript building tool.
Source map so that you can still get the correct lines.
Anybody beat the computer? Has anyone won? It's really hard, yeah. You could change the code to make the computer worse. Maybe have it run away from the ball or just be really slow. Yeah, exactly. Yeah, and then Yeah, that resets basically the game to the original state. I want to show you guys 2 more examples in the JavaScript stuff, and then we'll move on to Wekinator while we still have some time, and we'll see, like, some of the Wekinator stuff might spill over into tomorrow, depending on how much. We have about an hour left, but it will be nice to do a little bit of Wekinator also. So let me show you 2 more examples. And again, the examples. This is what I mentioned earlier today. If you came in a little bit late, so if you downloaded JS apps yesterday, you will not have PostNet in here. PostNet Music and PostNet Simple. I put those in just before I came. So if you have a moment and you haven't done this already, I hope most of you should have already done it in the beginning of the lesson. But you can re-download that in the ML4A demos releases page. Just re-download jsapps.zip and it will have those 2 files. Right? So how many people are downloading it right now? Most of you got it, right? Okay, so just please go ahead and download that and then just unzip it and you'll see that there are 2 new files in there. PostNet Music and PostNet Simple. Let's look at PostNet Simple. PostNet is another model that comes with Tensorflow.js, which is made to, and be careful, this has a bunch of long JS files also. You'll just want to go to index.html, don't click the other files. PostNet does, it recognizes location of body parts, basically, inside the camera. So let me run this for you and you'll see what I mean. So if you run this and then direct the webcam towards yourself, allow camera, and there we go. So what's going on here is that it's detecting body position points. And then it's printing them to the P5 sketch just down below. So if you actually like stand up, it'll get your whole body. We don't have enough room to really do this with everybody, but so, like, I don't even have enough room back here. So probably you're not going to be able to do this much until you have some space later. But this is what PostNet does. So it finds all of your body positions, gets legs too, if you can fit them into the camera. Yeah. Right. So that's pretty awesome. You have like full skeleton detection at a reasonably fast rate inside the browser. Like up until like a few months ago, you would have needed a Kinect to do this, which is a depth camera. So all that's doing in this example is it's taking, this is the built-in example. You can find this online. I just took it and I hacked it and I put in P5.js into it. So this on the top half just comes on, if you search TensorFlow PostNet, you'll find it. And this, and also besides for your skeleton position, it also gets your eyes, your nose, and your ears as points. And then I'm having it transport the points. If you look at the code and go all the way to the bottom, it receives the points right here from PostNet, the PostNet sketch, and then it just draws them and writes the text. So that's all that's happening right here. It's just like left eye, right eye, right? I made the canvas not big enough. It should be a little bigger. Maybe if I it says create canvas, best to make it the same size. I think it's 640 by 480. So if I reload that and then just reload the page, now it'll be the same size as the webcam. Oh, or even bigger. I guess the webcam is like 600. But anyhow, let's see what's going on here. Right shoulder, left shoulder. Right. So that's pretty cool. So what can we do with that? Okay, this will be the noisiest example so far, and I think I made this like just before coming here, so it's a little like wacky, but it actually sounds kind of cool. I think it's gonna make some music, so probably some people are gonna beat me to it. We're gonna start making a lot of noise in a second. So if you load the music example, let me do it first before we start to get a lot of sound here. And this is actually gonna synthesize some music, so. If I stop, it'll stop. It's got a lot of reverb. It sounds like a Nintendo, like Legend of Zelda or something. It's just a square wave. Sorry, I'll stop. Okay, I'll show you the code. You guys feel free to like start playing with it. I'm gonna turn mine off. So what's going on? Like it's all it is I took this from a few places. So if you go to p5js.org, I basically took in I think, where is it? Learn, I think. If you click on learn, no, it's examples. Click on examples, and then find sound. I basically like took one of these, and I don't remember which one. I think, so I combined the reverb with the note envelope. I think note envelope. So if you look at the example inside of P5, this does some like basic, I think I just copied this. Right, all this is doing is it's just playing some notes. This is the P5 script. What did I do? I added a reverb to it, and I got rid of the song. Like I made it not play this, basically, and I didn't draw it. And then I had it, and now basically I assigned each of those points to one of the notes. And then if you look at the code here, what happens is, like, I'm just showing, I know this is probably too abstract for most people, so so don't worry if you don't really understand what I'm showing here, but this is just for the sake of knowing which part I hacked. Basically it goes, for each point, look at the distance between it and where it was in the last frame. So I'm calculating the distance. I keep track of all the points and their previous position. And if their distance is less than 5, don't do anything. And if the distance is at least 5, it'll take the note, and then it will map the time to the Y position, and then it'll play the note. So something like that, like a simple little P5 thing, and then with a lot of reverb, and it sounds great. Like reverb makes everything sound better. If you want to see, watch, I'll show you. Like if you don't have the reverb, I'll just like get rid of the reverb here. If there is no reverb, then it's going to sound so much worse. Like it's unbelievable. That's kind of cool, actually. It's also, there's one more thing that's happening. It's a major scale. So these are MIDI notes. So how many people know MIDI? So these are the notes of C major, 60, 62, 64, 65, 67. And then what it does is when it plays the note, it also just does this little thing randomly where if a random number is less than 0.25, it'll add an octave to it. And if it's less than 4, it'll subtract an octave, and that's why you get these little jumps. Otherwise, it sounds just like, if you play the same notes from one scale and you add reverb to it, it sounds like music. So that's kind of that, right? So have some fun, like play with that. Maybe like you would also try messing with these. So like you can try to add, for example, you can try to change these numbers. We can make it minor. So minor would be, who remembers this? It's like 60, 60, 62, 63, 65, 67, 60, is this right? 70, right, that's natural minor. But wait, and then I,
Get rid of that 69.
oh yes, okay. So let's make it minor. And then let's put the reverb back. Minor definitely needs reverb, I think. So let's, hello?
I think you might have uncommented something.
Oh, that might be true.
JavaScript console is red.
Yeah. No, but it was, I think it was just, let's just try it again. That is weird. I can't. Oh, I screwed something up, right? I made a, I screwed up my code because this is a comment. Reverb time, yeah. There we go. Now it's sad. That sounds, is that right? Is that the minor? Is that right? Did I get that right? 60, 62, 63. Minor third. Major third, minor third, yeah. It's very aleatoric. Yeah.
Make that 67 into 66.
Yeah, right? Because we have a tritone, don't we? Wait, 67. Are you sure? No, that can't be. No, but then we'll have a tritone. Then it would be really ugly. If you have a tritone, it's the ugly scale. It's the.
That's like what is that?
That's the.
Some minor mode.
It's what do you call it? Phrygian, Lydian, Mixolydian, Locrian. Yeah, Locrian. It's very dissonant. Anyway, you can mess with that. I'll go back to my major scale because that's very Zelda, very Lord of Zelda, Legend Zelda. And you can also, like, if you want, like, okay, so if you want, you can oh, oops, and then this should be 69. If you go to the P5.js examples page, you'll see a lot of like audio examples. So if you click on one of these and then click on examples, and then in sound, there's all these audio examples. You can mess with them. You can do other things as well. Like you can, there's all of these other P5.js examples. You can try the delay. So if you look in any of these, they're all examples that you can run inside the browser. So if you run this, it should start to play in a second. Right, when I click it, it's showing you the delay pedal. So if we ran the rest of that through a delay, it would sound even better. It would be like, because there's already a lot of delay because of the reverb, but then it would just be like saturated with delay. So this is kind of like a strategy to playing with these things. You can, and for those of you who are not JavaScript aces, it's good to, like, if you want to start modifying these examples, you would try to learn a little bit of P5.js. There's a really, really easy to start with. You could go to download start. It's very welcoming. It's like it's like a very, very great introduction to creative coding and how to run a simple sketch. It gives you exactly what you need to know, and then you would learn how to do some P5.js, and then from there, you can go into these examples and start modifying them to interact with the Tensorflow.js, receiving classification or regression, right? So before we switch gears, are there any? That's the last Tensorflow.js JavaScript example I want to show for today. I think, unless any of these, I'll show a few of these really briefly, but we won't actually just so you see what they are. But we won't actually open these in brackets. I just want to show you the rest of them just so you see what they do. But otherwise, we're gonna kind of switch gears in a minute and look at some other stuff. Are there any questions like that people have? Any ideas? Any comments? Any compliments? You know, any money? Yes.
Maybe this is a silly question, but can you explain again what the relationship between P5.js is and TensorFlow.js? Is TensorFlow just the machine learning part and yes?
Yeah, so really there's no official relationship between them. They're just two different JavaScript libraries that do different things. P5.js is a library that makes it easy to create graphics and interaction and sound and like basically design and visual art in JavaScript. Technically P5.js is a rewrite of processing. So if you've ever heard of processing is much older. And is something that certainly SCM students will be familiar with. We're actually going to look at processing in a minute. Processing is the big brother of P5.js. It's kind of like an application which lets you write code in a nice and easy editor that then runs graphics and visual art, you know. But it's using Java. So the thing about processing is that it was developed so that people could do this stuff in Java and have little applets that make graphics. But the problem with Java is that it doesn't run on the web, or it does, but not very well. No one uses it. So P5.js came along to make a web-friendly version of processing. And then TensorFlow.js is another JavaScript library that's doing machine learning. And so these scripts that we have are just both at the same time. TensorFlow.js does all the machine learning and sends the results to P5.js for further processing. And for our purposes, like P5.js is much easier to use. So these examples are really like you shouldn't have to worry too much about the internal machine learning. You can just treat the machine learning more or less like a black box. And then what you're receiving inside of the P5.js sketch is the results of the classification or the regression. And then you can use that in all these clever ways. Right? Mm-hmm. Any others? Yeah?
Can you talk about how machine learning works with text? Or what we can be using?
So actually, like one of the examples here I'm going to show actually is an example of that. So just hold tight a couple of minutes and you'll see. Mm-hmm. Any others? Okay. So, and we'll have more time later for questions if you have any. So let me show you now. Like I'm going to show a few more of these, like the ones that we didn't look at, very quickly. So you don't have to open them. I just so you see what they do. They're kind of nice and magical. Some of the others are just ML5 examples, just packaged here. So you can find those in ml5.js. So if you look at LSTM, let's look at the LSTM text. So this is going to answer your question about text. So LSTM stands for long short-term memory. And LSTM is a type of neural network. More specifically, it's a type of recurrent neural network, which we don't have time to get into the details, but I'm just giving you the one-sentence description. Recurrent neural networks are neural networks that can operate on sequences of data. And text is a sequence. It's either a sequence of words or a sequence of even characters, if you let it be one. And one of the most popular things to do with recurrent neural networks is to make text bots. So if you run this, you'll see that what it does, it launches a very simple program that lets you put in some text. So like, we were at the university when, and then let's make the length really high. Let's leave the temperature at 0.5 and generate. Click generate, and it might take a while. Okay, then it goes, we were at the university when the people are very carefully at the store, which at the moment, and of the from officers were not big, gray of E, and delicious of the weather. There were 3 maps after the drunkards. Why they had ridden while they were playing the firing and the closest automatic weapons to the left eye. There had been too late to Inspirus, of all the drawer of manure one never before. It was an order with a possibility. That's profound, isn't it? It was an order with a possibility. I do not know what had been defended to the letter to the Grand Via, and he said that he could go. Okay, what is this thing doing? It's basically, and you can generate again, and it'll make more of it. So click that again, and you can seed it with some other. We were at the university when they are still away. So basically, in LSTM, one thing you can do with it is you can feed it text from a book, let's say, or from any large text file, and it will learn how to predict characters. It's a generative model. Basically, it'll produce text that looks like it came from the data set you gave it. So in this case, this was trained on Ernest Hemingway. You guys know the author Ernest Hemingway? So this was trained on some of Ernest Hemingway's books, and now it makes text that sounds like Ernest Hemingway. And there are, I don't know how they have it here, but there are ways of training these on your own. Sometimes I make them part of my classes. Maybe we'll do that actually later in the week. We can train one of these on a text file. I've trained it on books, like I've trained it, that's the common thing to do, is to just download a book. You can train it on the Bible, like anything you can find online. Just like it's at least a megabyte long. I've also trained it on my own emails before, and things like that. So like I make a text bot that writes emails like me. And it doesn't make a lot of sense if you read it for long enough, but it's kind of cool. And people have made whole art projects based off this technique. So here, let me show you a few. Like this guy, Ross Goodwin, who was a student at ITP, actually, so the place that ml5 is being developed. He made this thing called Lexicon Jure, which it makes up definitions every hour. It's a Twitter bot. It makes up definitions of words. So it's trained on a bunch of dictionaries. And it goes, Eritrean, a person who is expensive or confident in the era of an election. Larianter, a small swelling on the skin of a plant, typically eaten as a source of sugar. Enton Terry, a man who is not a person of formal and exciting and complex statements. Simperme, a small piece of music that is designed to be considered to be a person of unspecified performance, or yeah. So, and it's a Twitter bot. So let's. No, not that. Oh, you can. Oh, so you can tweet to it, and it'll generate a definition from any word that you give it. So wait, and it's. Yeah. And this is its love, a person or a result of a person or animal's response to a problem or difficulty. She loved the music of the new employee. So that's pretty neat, right? The same guy made this movie called Sunspring. Did anyone see Sunspring? So this is a whole movie that's using one of these LSTMs. It's trained on a whole bunch of sci-fi. So yeah, this was made with the first actor from Silicon Valley. And it was trained on sci-fi, so all these books. We'll just watch like a minute of it. It'll at some point it just keeps going. So it wrote a screenplay, and then they get actors to act it out.
In a future with mass unemployment, young people are forced to sell blood. I can do.
see the boy and shut up. I was the one who was going to be 100 years old.
I saw him again. The way you were sent to me. That was a big, honest idea. I am not a bright light.
Well, I have to go to the skull. I know.
What do you mean?
Well, I don't know anything about any of this, so.
Then what?
There's no answer.
We're going to see the money.
All right, you can't tell me that.
Yeah, I'm coming to that thing, you know, because you're so brilliant.
I don't know. I don't know what you're talking about.
That's right.
So, what are you doing?
I don't want to be honest with you.
You don't have to be a doctor.
I'm not sure. I don't know what you're talking about.
I want to see you too.
What do you mean?
I'm sure you wouldn't even touch me.
I don't know what you're talking about.
This wall is completely constructed at the same time.
It's all about you to be true.
You didn't even watch the movie with the rest of the base.
I don't know.
I don't care.
I know. It's a consequence. Whatever you need to know about the presence of the story. I'm a little bit of a boy on the floor.
All right. Anyway, it just goes on like this. You can look it up. It's Sunspring, yeah. So a lot of people have made art projects like this, and there's like you can find Twitter bots trained on various things. The one that's trained on Donald Trump, and it just makes a bunch of nonsense. The original, there was a blog post by Andrej Karpathy called "The Unreasonable Effectiveness of Recurrent Neural Networks," where they described this kind of started the craze like a couple of years ago. Where basically they described writing Shakespeare, so this is all fake Shakespeare. Pandarus, alas, I think he shall become approached in the day when little strain would be attained into never being fed. Wikipedia articles, naturalism and decision for the majority of Arabs country, capital A. It would make XML, completing page tags, which is really cool. Math papers. So math papers use LaTeX. So these are LaTeX is just a markup language that generates equations. So maybe some of you know it. So it's like, and in the fiber product covering, we have to prove the lemma generated by Z. So U equals. Sorry. Proof, see discussion of sheaves of sets. Actually, so they have the PDF, and actually one of them is really funny. It's like, I think it's 3. Yeah, this one. Proof, omitted. Let C be a set of the construction. Let C be a gerber covering. It's beautiful, isn't it? They trained it on Linux source code. So code doesn't compile, but comes close. It even makes up its own bogus comments and everything. Free our user page's pointer to place camera if all dash. Now we want to deliberately put it to device. It almost makes sense. So yeah, we'll maybe possibly train one of these later in the week. That's always a fun thing to do, but that'll depend on how easily we can get good GPUs in the cloud, because you can't do it on your computer. Okay, so let me show you a few more examples, and then we'll probably leave the Wekinator stuff for a bit later. So now this is, again, just to be quick, I want to show you the style transfer ones. I think I showed this to you yesterday. So style transfer, this one's really neat because you can do style transfer on your camera. It doesn't work super fast, but that it works at all on the browser is actually pretty amazing. So this is doing style transfer in a painting. Okay, so then it might take a little while to start. Oh, you have to click start. Oh, I might have, yeah, I think I made the canvas bigger, but basically, yeah, it's gonna, yeah, there we are. The reason why there's a big red canvas is because I modified it so that the canvas would be bigger, but that was just in a normal example, it would just be the same size. And also, there is another style in there. So this is the style is Young American Girl, the dance by the artist Udni. Francis Picabia. Anyone know Francis Picabia?
Yes.
I don't. Yeah. Is he? How famous is he? Pretty famous. Yeah. Where's he from? France? Okay. Well, anyhow, and actually you can modify this because okay, it has it. See where it says down here. Udni. Where's the? Oh, it loads the model here in Sketch. It loads model Udni, and actually there's two models in here that you can find. There's one inside images of Wave right here. So we can actually grab Wave and copy it into the style transfer video inside of models. And then Wave is the Great Wave of Kanagawa from Hokusai, Japan. So if we change this to models Wave and copy that over, we can run it. And then we didn't change the image here, but imagine Hokusai. Right, this is that. Right. So style transfer is kind of a nice little magic trick. Of course, like there's one thing that's about style transfer that like you can't do much more with it than just make it the center of a web app, right? Because it's just like the effect of it is so overpowering that it feels gimmicky to like write anything around it. So I don't usually like use it in workshops because that's it. That's all it does. Like you can train your own. That's one other thing, but that's more complicated. So we might not really have time to do that. But in any case, there's two styles that come with it. Probably there'll be like at some point they'll get around to making a database of others, I would assume. Let's see. Are there any others we want to show in the TensorFlow models? Let's see. So we looked at all of these: style transfer, regression, PoseNet, LSTMs. K&N image classification we don't have to worry about because basically the classification simple is like a better version of that. And then image classification we looked at, and then the last one are the face tracker ones, which I showed yesterday, right? So the face tracker, I showed this yesterday. Basically, this was the example that we ran. But basically, we can, if you want to do the face tracker example from yesterday, it's not going to work well in low light, but it's worth trying. So allow camera, not bad. So we can train it to do one. So like, let's say class 0, click and hold the mouse. Then 1, I'm gonna change to 1 and then smile. And now for 2, there's a bug here. There's a sound duplicated. It should be C, F, G, and then it should play. When it receives the prediction, that happens. Where is that? Last class. I have to find it in the code where it receives the prediction. Image. Sketch.js. It should receive it somewhere, but I can't remember where. Because it's playing the same sound for both of them. I think, well, anyway, like another little bug. Point is like it's playing sounds, playing guitar. Okay, so those are basically the JavaScript examples. You see that they run in your browser. You can easily upload them to a website, and you can modify the P5.js script to get some other cool effects. You can build games around it. Lots of things you can do, and it's kind of nice because it can go directly on the web, and so on. Any questions about that? Okay, so this took longer than I thought. I thought maybe we'd have time for Wekinator, but so here's what I want to do actually for the rest of the time. Maybe I'll introduce Wekinator right now, and we'll kind of do most of it tomorrow. We'll get back to Wekinator stuff tomorrow, and then also the plan was to do Wekinator, and then let's just see. So like we can do basic Wekinator, and then actually one thing that I'll want to do before we all get out of here is to see how much strain on the internet we put if everyone is on the Google Colab instance. And then, in fact, okay, I'll do that after introducing Wekinator briefly. We'll do that, and then that'll be the day. So we just have like 20 or so minutes left. So here's what I want you to do. I want you to unzip if you haven't already done this, unzip Wekinator processing. You should have this folder here. Everyone has this, yeah? So you should have gotten it yesterday. And you should have also gotten from the Mac install or Windows install, you'll have a zip file that contains Wekinator in it, so wekinator.zip. So you should be able to start Wekinator. So you should be able to, when you start Wekinator, you should get a screen like this. I just want to know like how many people have this? See it? Okay. You should have downloaded it.
But in the Wekinator zip.
Yeah, so it should be inside there. Oh, in the Wekinator? Wait, let me see. Hang on, because I don't know how it is. I don't know how it is with Windows. On the Mac, it's a. So yeah, if you unzip Wekinator for Windows, there's an executable file in there, right?
Yeah, so if you go to the link to Wekinator, you end up with just the Wekinator processing file.
What do you mean the link?
Like at the bottom of your page, it says like there's a link to Wekinator.
Yeah, but there's also this Wekinator processing.zip, and then Windows install or Mac install will have the actual zip file for Wekinator in it. So a bunch of people have it, right? So some people on Windows already have it, right? Does it work for Windows? Anybody? Yes? Okay. So how many people are still looking for it? Raise your hand if you've got Wekinator open. Okay? Okay. So we don't have enough, so much time left over, so I'm going to do like a very brief introduction to what Wekinator is. So first of all, Wekinator, what we show in Wekinator is going to be quite similar to the stuff that we've been doing in JavaScript so far, except it is made to work not through a browser, but basically through applications on your computer, so desktop applications. Now, a lot of the same stuff, they're kind of cross-functional. So like both of Wekinator and the Tensorflow.js examples, they will repeat a lot of the same stuff. But the difference is that Wekinator is optimized to work with like with processing, number one, which means that you have access to all the processing libraries, and those are going to be probably a little bit cleaner in terms of the code that you've seen so far. But for the most part, like these two things are quite related. So we may be able to kind of even go through it briefly tomorrow. But let me describe what Wekinator is. So for those of you who haven't seen it, if you go to wekinator.org, you'll see this website that is basically, Wekinator is a piece of software that was written by Rebecca Febrink, who is a researcher at Goldsmiths. University, and she used to be at Princeton when she developed this. I actually got to see Wekinator when it was first being developed because Rebecca was a graduate student at Princeton when I was an undergraduate at Columbia, and Columbia and Princeton have basically like for many decades, they had a combined music technology program. So there's actually a lot of interaction between the two. So I got to actually see this right when it developed. And Wekinator basically was the first tool for letting musicians and artists, especially musicians, work with machine learning. And it is designed to handle all of the machine learning for you. It's an application, this application, which by itself doesn't make any sound or make any visuals. It just has a built-in machine learning framework, like it creates neural networks, which accept inputs and transmit outputs. And what those inputs and outputs are up to you. So you can make the inputs be input from a camera, or input from a microphone, or whatever. We'll see a bunch of examples. And then the output is going to be going somewhere else, output to some visuals or output to some sound. But fundamentally, those things are actually implemented on separate programs, and Wekinator is kind of the glue that lets you make one thing control another. So it's kind of the glue, it's like the intermediary, and it implements all of the really, really ugly stuff for us. Collecting data, instantiating a neural network, training it, and so on. And it communicates using something called OSC, Open Sound Control. How many people here are familiar with OSC, Open Sound Control? Maybe 1/4 of you? Not even? Okay. Well, OSC is basically this. So OSC stands for Open Sound Control. And although it stands for Open Sound Control, it actually doesn't really have anything to do with sound. It was originally developed for sound at the University of Berkeley. It was supposed to be a successor to MIDI. So how many people here are familiar with MIDI? Okay, more of you. MIDI is kind of how electronic music synthesizers work. They communicate information with each other. It's a very old platform, very old standard. It was developed in something like the 1970s, and to this day, it's like still in most music, like analog music software and synthesizers, even though it's horribly outdated because MIDI has it's 4-bit or 8-bit, which means that all the numbers are between 0 and 128. So because that was very precious. Your bits were very precious in the 1970s, and now but because there's all this legacy software and hardware, MIDI is still the standard for all this music stuff. OSC is came along. It's much faster. It's much better. It's much more granular, but it still hasn't been able to beat all the legacy software. So instead, people use it as a communication medium and creative coding toolkits. That's for the most part what its general use case is. Technically, OSC is a type of network packet. It's closely related to UDP. It is a type of UDP, which is the protocol by which network packets, something like network packets, get sent over the infrastructure of the internet, more or less. I don't know if I got that explanation right. Someone here probably knows it better than me, but that's basically what's going on. And for our purposes, what it lets us do is it lets us communicate between applications. In this case, we're going to communicate primarily between Wekinator and processing. And so I'm going to show you a basic example. We just have time for one basically, and it's not going to be interesting. So it's going to just be like the pipes. So maybe it'll make sense for me first to introduce processing. I think let me just think on my feet here. So here's what we're going to do. We're going to introduce processing right now, and then actually leave aside Wekinator for tomorrow, because we're going to be using processing and Wekinator together, but I don't want to introduce too many things in the last 15 minutes. So instead, let's introduce processing, and then we'll do the Wekinator examples tomorrow. So you can get out of Wekinator and open processing, if you've gotten processing, you should have something like this. Once you've unzipped it, you can open the application. How many people see this? I'm going to make my text a little bigger. How many people have successfully opened processing? Okay. Some people looking for it. So basically, just in case you don't know where it is, you should have downloaded it today or yesterday. If you're on the Mac, it'll be inside the Mac install zip folder. If you're inside Windows, it'll be in the Windows install folder. And you'll have an application called processing. And when you open it, you should get something that looks like this. Okay? Raise your hand if you got processing open. Okay? Is anyone having trouble finding it? Okay. So you should have downloaded it. So I'm going to just do a basic introduction to processing for now, and just to give you a sense of what it can do. And then, so first of all, let me tell you what it is first, and then I'll show you a quick demo. Processing is very closely related to P5.js. In fact, P5.js is a project that of the Processing Foundation, the same nonprofit that makes processing, also makes P5.js. Processing came before P5.js, so we actually showed them out of order. Processing was developed in something like early 2000s, like 2001, 2002. It was developed by a couple of grad students at MIT Media Lab, and it was basically supposed to be an introduction to coding for artists and designers. And it was really the first of its kind, right? Like we have all these media art programs now that do teach coding to non-computer scientists, in particular to people in the fields of art and design and related fields. And processing was really one of the first projects that tried to do this at a mainstream level. So it existed up through the 80s and 90s, but it was really just a small academic thing that just graduate students who happened to be good at art and design, but also knew like computer science could do. And then a couple of grad students named Casey Reese and Ben Fry, they decided to make this programming environment which would let people very easily get sketches, what they called sketches, of code that would do basic things. So let me show you like a few quick examples. So first of all, it works it's very similar to P5.js, the semantics of it. P5.js is meant to be the processing of the web. So, and it's a much younger project, but it works in a very similar way, except it's based on Java instead of JavaScript. So we're going to be using a totally different programming language. And this is just kind of the thing, like you get used to it, like all these things come in different programming languages. We're going to see Python later also in the course. Python, JavaScript, Java, maybe even some C++, or Lua. You just become like good at many programming languages the way that we're good at like multiple languages. How many people here speak multiple languages? Pretty much everyone, right? So it's just the same with code. Anyway, I'm going to make my font a little bigger. And the way processing works is 99 out of 100 programs, there's going to be two functions in there. Void setup and void draw. And if you look at this, Java is very particular about its syntax. To create a function here, you go void. Void means there's no return type. And this function gets run once. And what gets run is everything that's in between the two braces. And then it will begin to continuously draw the draw loop here. This gets run 30 times per second. So what you do in setup is you create a canvas. You say what the size of that canvas is. In P5.js, you saw this before. It was function setup instead of void setup, and it had create canvas instead of size. Otherwise, a lot of the variables are going to be very similar. So ellipse and rectangle and stuff like that. So size, let's say 500 by 500. That means it'll create a canvas of 500 pixels by 500 pixels. So if you run this, you'll get a blank canvas. That's 500 pixels by 500 pixels. And then in draw, we could say, okay, how about we make a red background. So background 255.00. This is red, green, and blue. So 0 green, 0 blue, and 255 red gives us a red background. And if we want to make a circle, a white circle, let's say, fill 255, 255, 255, and we'll make ellipse at xy of, let's say, 200, 100. That's the x and the y. So this is where it will be. And then the size, the width and the height. So let's say the height is, 150, and the width is 150, and the height is 100. So if we run that, we get a white ellipse at 200, 100, whose width is 150, and whose height is 100. So do you guys see the basic semantics of processing? It's relatively straightforward. Like, if you've never seen this before, this will be obviously like very new for you. However, it's designed to be, if you look at what actual C++ or Java looks like, this is a big simplification of it, and it's meant to be readable by computers and by artists and designers, and kind of accessible in this way. It's a little bit funky because it's Java, so you have to be really careful. Like if you forget a semicolon, the most common mistake that beginners make is you forget a semicolon. Like watch what happens. If I forgot a semicolon and I try to run this, it goes syntax error, maybe missing a semicolon. And I go, hey, what did I do wrong? And it's just because there's no. If you actually make this mistake in JavaScript, it'll actually keep going. So JavaScript is much more permissive of mistakes. But Java is like really, really like hardcore. So you have ellipses, you have rectangles. You can make like a green rectangle, right? Rect, 100, 100, and let's make it 600 by 200. So it'll be bigger than the screen. So here's a rectangle. You have triangles, you have Beziers, okay? And the thing is, what's cool about this is that it's really easy to get started. Because, well, we've already gotten started. And watch how quickly you can go to making something cool. So this is my minimal cool example. We're gonna make a Bezier curve. So a Bezier is a type of curve. You have Beziers in Photoshop. If you ever use Photoshop, there's a Bezier tool. It takes in 4 XY points. So we'll call them XY, Y1, X1, Y1, X2, Y2, X3, Y3, X4, Y4. And now we don't have these variables. So like if we say float X1 equals, 20, and we'll do this for like all of them, but give them different numbers. So X2, X3, X4, float Y1 equals, let's say, and these we'll make them all different. So these are all a bunch of points, and they'll make a curve. So like 100, 200, negative 50, 150, 250, 78, 72, 500. So let's see what that looks like. So it's down here somewhere. Okay, it's off the screen. Maybe let's make this 350. Now it's down there. So this is a Bezier, and it's filled white. We can unfill it, so it's just a line. So we say no fill. That means it'll just be the line. And we can say no fill. We'll say then stroke. Like we can make it a different color, right? So now it's green. Now let's get rid of now let's do something cool though. So let's make it white background. And let's make these random. So we'll say random width. So that will give us a random number between 0 and width, which is the width of the canvas. And this, for the y's, will give it a random height. So now it's going to keep drawing random Beziers. Let's make it a little darker so you see it. So stroke 0. Okay, well, that's cool, right? Sort of. Now let's do something cooler. Let's use something called noise. How many people here have used processing before? Okay, so like a good number of you, so probably a lot of people are familiar with noise. For those who are not familiar with this, don't worry, like this is just a demonstration at this point. Like you don't have to, because I'm going to show you something that usually would take me 30 minutes to explain in an introductory processing class. I'm just showing you something cool so you know you can do something cool with it. So I'm going to use noise here. We'll say width times noise of 0.01 times frame count, and then 5. Now don't worry why I'm doing that. We're going to have all of these modulating with noise, and they'll all be like different numbers here. And then we'll copy that and make this height, and this will be like 20 or 105. So this, oops. So this, and we'll make all of these numbers different so they're not all the same. And now you have this Bezier that's like moving around organically, right? That's all it took, right? Now watch what happens. What if we do the background, we only make the background white once and collect all of these to the screen? And what if we also make this a little lighter? So now we have something a little cooler. Maybe let's make it even lighter and slow it down. So, and also like let's make it bigger. How about instead of this, it'll be negative width plus 2 times width. So we'll make it much bigger. And then this will be height. So now it's going to kind of oscillate around the screen and slowly aggregate, or where is it? I've lost it. I think it might be off the screen. Let's see if I tried it again. Oh, I totally lost it. Where'd it go? Oh, maybe it's just too light. So 0, 100. Okay, maybe that negative height thing was a bad idea. Oh, there it is. It's just off the screen. Okay, maybe I'll get rid of the negative.
It's because you're multiplying.
Well, yeah, but it. Well, that because I wanted to go from negative width to Oh, I should do it put times 3. Whatever. It's not important. It's like we'll just make it like this. So it'll collect to the screen. So I would encourage you to mess around with processing because we're going to be using it like a fair bit tomorrow. Maybe make it lighter. So this is like my introductory processing generative art, right? You can make like cool things with generative art. Oh, it's like off the screen. Okay, so it's 8:59. So I want to do one really quick thing before we leave. I just want to test something. Basically, I'm going to put a link on the pastebin, and I want you. Basically, I want to test how fast Google Colab works. This is for me to plan for the next few days to see if like the internet is going to allow us all to use Google Colab instances. I'm sort of not super optimistic, but maybe I'll be surprised. So here's what I want you guys to do: go to pastebin.com/ what we are going to you make a new pastebin here, and I'm going to put in a link. I want you to copy the link from here. Or does it make sense for me to just do the bit.ly thing? Yeah, let's do that. Here, I'm gonna go to bit.ly and copy this and shorten the link. So first of all, how many people here have Google accounts? Most people, right? So some people don't. We may or may not use this, but in order to use this, you'll need one. You don't actually need one to load it right now, but you'll need one later if we want to use it. So is that okay? Yeah. So please copy this link. bit.ly to capital L 5 capital T lowercase p capital F. Okay, I want to load this page right now and see if this will work for everybody. We're basically going to bombard Google, which is okay. We're going to bombard the GPUs. So what you want to do is copy that link. Does everyone have it? Oops. Okay, I want you to enter that into a URL and open the page. Raise your hand if you're still copying. Okay, I can zoom out. Okay, so everyone's got the link.
It gives an error saying that, wow, this file is really popular.
Oh, really?
Yeah.
Oh, that's not good. Hang on a second. Oh, really? So maybe, I didn't realize that. Maybe they don't let you load the same notebook many times. So how many people see this? A bunch of you, but a lot of you got some error that says this is popular. Try to reload it. And then you get this pop-up that says you can't use it?
No, you get this.
Oh, you do get this. Did you get?
I keep getting the pop-up.
Really? How many people are getting a pop-up that says this file is too popular? What does it say exactly? This file is.
This file is just, it's very popular. Now I get another error.
Now you get it in offline mode. Are you in offline?
Yeah. You'll have to then click on Playground basically to get it running. But I just want to know how many people can run. So okay, raise your hand if you see what I see, and raise your hand if you do not see what I see. Only you know? Just so everyone else is seeing it. Okay, so I don't know. Something's
Have this Firefox again?
maybe.
I'm not paying attention.
Okay, so again, I'm sorry to keep doing this. Show of hands, how many people see this? Okay, now I'm going to try the next thing. You should see in the top left somewhere, it should say Open in Playground, right? And first of all, you have to be logged into Google. So click Open in Playground, and you should get the same thing, except now you'll be able to actually work with it. So you should see something like Connect and Editing in the top right. Can I see really quick? Next to the, let me see. Okay, so if you see it says offline, it seems to be okay. Like this, it might say offline, but it's working for at least one person. So basically, like see over here where it says connect, click connect, and it'll say allocating, connecting, failed, initializing. I'm connected now. Now you got it? How many people it says failed for? Can I see? I want to see like if this is. No, you're good. Yeah, just connected. Now connected. Yeah. Just click connect. There's a button at the top right that says connect. Are you not logged into Google? No, you're not logged in. You should have a link that says Open in Playground. Okay. All right. So for those who that didn't test, and then we can leave. Basically, when you go down here, scroll down, and you'll see there's a cell here that says grab inception model from online and unzip it. So I want you to, if it says connected over here, I want you to see this play button right here, run that, and then tell me if you start seeing output like ... and then resolving storage, blah blah blah, archive, all of this. Well, it'll be there already, but if you run the play button, it should become blank, and then it'll download some stuff. So for how many people is that working? Okay. Warning. Did someone? Can I see? Oh yeah. If you get a warning that says it says just trust me, right? So this notebook is authored by me, not by Google, so it's fine. Actually, technically, it was authored by Google and then modified by me, so it's fine. You can trust it, yeah.
But you can trust Google anyway.
Exactly. You can always trust Google for everything. Deepest, darkest secrets. So okay, raise your hand if that seemed to work. Okay, this is encouraging. How many people did it not work or have not seen output? Raise your hand if you're having some kind of problem. Because some people didn't raise their hands at all. So I'm still curious, if that worked for everyone, that means we can do some really awesome stuff later in the week using Colab, and that will simplify a lot of installation stuff. So again, raise your hand if that worked, and then okay, let's try 2 more cells. Okay, next cell right here, where it says from future, blah, 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 from IO import, click the play button here, and then it should spin around for a little while, and then at some point it should stop spinning. It may, hopefully it doesn't, okay, then stop spinning. It doesn't actually provide any output. But if that spins for a while and then stops, that seems to be, that's probably good news. Did that, for most people, that work?
The first one is stuck on from stitch.
Can I see? Yeah. Oh, because you did it twice. Because I already ran it for you earlier, right? Yeah. So that's what you can. Yeah, you can get. Okay, so that's all I wanted to do. I wanted to test that. That's good news. That means that's something we'll probably do on Wednesday. This is a really cool notebook, and it'll let us make some really cool graphics. But that was just a test for me to plan. Okay, so tomorrow we'll do Wekinator stuff, and then probably Wednesday we'll introduce that notebook, and Thursday we'll introduce the notebook. Tomorrow's Wednesday. Okay, so are there any questions before we stop? Oh, when you can just close it. Yeah, don't worry. You can just close it. And for those of you who want to use this who don't have Google accounts, just sign up for a Google account. Trust them. So you don't have to sign up. Obviously, I won't make you, but this will let us. There's other options for this, but this will be the easiest one. So we'll look at that on Thursday. Okay. Cool. See you guys tomorrow.